Alright, in this video we're going to talk about just the basics of logarithms, what they are. The definition. If r is any positive real number, then the unique exponent t such that b to the t equals r is called the logarithm of r with base b and is denoted by log base b of r. This is a very important definition right here in bold. Log base b of r equals t. This sentence can be equivalently written as b to the t equals r. If I give you an exponential equation and say write this in logarithm form, that's how you would interpret it. Or if I give you the logarithmic equation and say write this in exponential, this is how you would interpret it. Let's practice this concept. 2 to the 7th equals 128. I want you to write that exponential in logarithmic. So we will actually say log base 2, the exponent base is 2, so the log base 2 of 128 equals the exponent. You're always equal to the exponent. 10 to the negative 1 equals 0.1. So this is log of base 10 of 0.1 is equal to the exponent negative 1. Now, if a logarithm has a base of 10, we actually don't even have to write in the 10 because it's called a common log. 2 to the minus 2 power is equal to 1/4. So log base 2 of 1/4 is equal to the exponent negative 2. Vice versa, we can write a logarithmic statement in exponential form. Log base 3 of 81 equals 4. So the base is 3 to the power of 4 equals 81. And that's true. 3 to the 4th power is 81. Log base 10 of 10,000 equals 4. That means 10 to the 4th power equals 10,000. And likewise, log base 2 of 1/16 equals negative 4. That means 2 to the negative 4th power is 1/16. And those are true statements. So using that definition, let's see if we can figure out some just basic logarithms here. Evaluate them. Find out what the power would be. Log base 2 of 16. What you're asking here is 2 to what power would equal 16. So in this case, x would equal 4. 2 to the 4th power is equal to 16. 3 to the what power equals 81. Well, x is equal to 4. So log base 3 of 81 is 4 because 3 to the 4th power makes 81. And 7 to what power is the square root of 7? Now we know the square root is the 1/2. So x would actually be 1/2, the power. Same way here. 8 to some power equals 1. Well, any number to the 0 power is 1, so x would equal 0. 2 to some power is equal to 1/64. Well, since it's 1/64, we know that it's going to be a negative number. So what power of 2 would give me 64? It's actually the 6th, so the negative 6 would be what we were looking for. The power we're looking for is the negative 6th. So using the definition, we're going to solve some equations here as well. Log base 9 of x equals 2. So we know that 9 to the 2nd power is equal to x. So 9 to squared is 81. So that would be the solution to that equation. 4 to the negative 3/2 equals x. Now, if you remember from your earlier algebra courses, when you raise a number to a fractional exponent, the denominator is the root. So square root of 4 would be 2. And then raise the numerator to that power. So 2 to the 3rd would be 8. So square root of 4 is 2. 2 to the 3rd is 8. Also, since the power is negative, we know it's going to be a fraction. So square root of 4 would be 2. 2 to the third is 8. It would be 1/8. All right. X to the 1/2 equals 2. Now we know x to the 1/2 is the same thing as square root of x. To solve a radical equation, I'm going to square both sides. So x will equal 2 squared, which is 4. Hopefully this video will help you understand the relationship between logarithmic expressions